Hello, this video is part 2 of simplifying radicals. For your reference, I have included the parts of the radical, the index, the power, and the radicand. We'll start with breaking down square root of 63 v to the first power to simplify it. Pretend for now that v to the first power is not there and solve it like you would solve it if there were no letters. 63, let's break it down into its smallest factors. 7 times 9 is 63. 7 is a prime number. We stop there on that side. 9 is 3 times 3. Therefore, 7, 3, and 3 are the leaves in this problem. Let's write them down in exponential notation. 3 to the second power times 7. Now, the index is 2 because there is no number there. We will be simplifying it and taking numbers outside and leaving some inside the radical. Now, we said that the index was a 2. That means that everything we group, we want to have an exponent of 2 or lower. 3 to the second power already has that. 7 to the first power already has that. Now it's the turn of v to the fifth power. We have to break that down because 5 is bigger than the index. So we'll break it down into v squared times v squared times v. If you add the exponents on the v, 2 plus 2 plus 1, that gives 5. So we did it correctly. Now to determine what goes outside and what stays inside. Anything with an exponent equal to the index, in this case the exponent of 2, will be going outside the radical. The 3 goes outside, the first v goes outside, and the second v goes outside. Again, the reason why we do this is because we have 3 squared. The index is a 2, so we put it underneath, and now we have 3 to the 2 over 2, which is 3 to the first power, and that's why the exponent right here is no longer there. Anything, going back to the problem, anything that doesn't have an exponent of 2, that it has a lower exponent, goes inside. 7v stays inside. Let's simplify it some more by combining terms. So we have 3 v times v is v squared. The index of 2, we don't have to write it down, 7v. However, if you want to write it down, it would still be correct. It's up to you. Just make sure that if the index is bigger than 2, you do have to write it down. Next problem, we have a negative 2 on the outside, which we'll take care of at the end. Let's start by breaking down 500. This breaks down into 5 times 100. 100 is 10 times 10. I stopped at 5 because that's a prime number. 10 is 2 times 5, and the other 10 is also 2 times 5. So these are the leaves. 5, 2, 5, 2, 5. In exponential notation, that would be 2 to the second power times 5 to the third power. Bring down the radical. In this case, the index is given to us, so it's 3. We have to put the index of 3. And also, we have to group everything with the exponent being 3 at most. This one has an exponent of 2. We're okay with that. The 5 has an exponent of 3. We're okay with that. Let's take care of the letters now. X to the 8th power. We have to break it down into exponents of 3. X to the third power times x to the third power. If we add those two exponents, we have 6. So we need to put x to the second power. 3 plus 2 is 8. And that's what we have to start with. Also, for the y to the third times y to the third times y gives us y to the 7th, and z to the third power. Now let's determine what goes inside and what goes outside. Anything with an exponent equal to the index, in this case an exponent of 3, goes outside. That one, that one, that one, that one, that one, and that one go outside. So let's write 5 x, x, y, y, z. Anything with an exponent, anything not highlighted goes inside. 2 squared. When you put it inside, you keep the exponent. Bring down the negative 2 and multiply everything. Negative 2 times 5 is 10. The x's become x squared, y squared, z.